Oxidation-reduction reactions, often called redox reactions, are a type of chemical reaction where electrons are transferred. One of the most common types of redox reaction that most people are familiar with is the rusting or corrosion of iron metal. Iron metal can react with oxygen gas to produce a bunch of different iron oxides. And that process where the silvery iron metal converts into a brownish orange color is the result of a redox reaction. Every redox reaction has two components. It has an oxidation and a reduction. The oxidation process is the one where one of the reactants in the reaction loses an electron or more than one electrons. And the reduction process is one where one of the reactants gains one or more electrons. And it's important to point out here that you can't have one of these processes happening without the other process also happening. So the oxidation involves a reactant losing an electron. And that electron is the one that the other reactant gains during the reduction process. The two things have to happen together. And there is a series of mnemonics that people use to remember oxidation versus reduction. One common one is oil rig. And this mnemonic simply stands for oxidation is loss and reduction is gain. And the loss and gain are of electrons. So I'll give you an example of a very simple redox reaction. In this example, we have solid iron reacting with aqueous nickel ions, and the reaction produces aqueous iron ions and solid nickel. In this example, it should be fairly easy to see which reactant was oxidized and which one was reduced. The iron goes from a neutral situation, iron solid has no charge, and it converts into iron 2+ ions. So it's more positive, which means the iron must have lost electrons. So that means the iron was oxidized. The iron solid had to lose 2 electrons in order to end up as iron 2+. And those 2 electrons that were released were used by the nickel ions to convert from a 2 positive charge into a neutral nickel solid. And there are a couple of other bits of terminology that are worth knowing, and these terms are oxidizing agent and reducing agent. The oxidizing agent is the thing that causes the oxidation, and that means that it itself has to be reduced. So in the example that we've given you, the nickel 2+ is the oxidizing agent. It causes the iron to be oxidized. And the reducing agent follows the same kind of rules. It is the thing that causes the reduction and is itself oxidized. And again, by the same process, you can see that the iron solid must be the reducing agent. It causes the nickel ions to gain electrons, and in that process, oxidizes itself. And this oxidizing agent, reducing agent language is based on historical observations. Consider the example of magnesium metal reacting with oxygen gas to form magnesium oxide. It's important to note that the magnesium solid is neutral, and the magnesium that's present in magnesium oxide is an ion. MgO is an ionic compound made from a metal and a nonmetal, and the charge on the magnesium in MgO is 2+. In this example, magnesium goes from a neutral solid on the left-hand side to a 2+ charge on the right-hand side, which means the magnesium must have lost electrons. And that means that the magnesium was oxidized. Historically, it simply meant that the magnesium gained oxygen as in this reaction where it forms MgO. But later it was generalized to mean any situation where something loses electrons. In this case, the oxygen simply takes the electrons from the magnesium. So the reactions of metals with acids or salts are a very common type of oxidation reduction reaction.